Chapter 10, Section 5. Learn to use probability to make decisions and predictions. How do I use probability to predict relative frequencies of outcomes? Let's decide whether a game is fair. In a game, two players each flip a coin. Player A wins if exactly one of the two coins is heads, otherwise player B wins. Determine whether the game is fair. First, let's list all the possible outcomes. Find the theoretical probability of each player's winning. Probability of player A winning is 1/2. For player B, 1/2. Since they have the same probability of winning, the game is fair. In a new game, two players each flip a coin. Player A wins if at least one of the two coins is heads, otherwise player B wins. Determine whether the game is fair. List all possible outcomes. Find the theoretical probability of each player's winning. Player A wins in 3 of the 4 situations because now we're looking for at least one heads. Player B only wins 1/4 of the time, therefore the game is not fair. The table shows the satisfaction rating in a business's survey of 500 customers. Of their 240,000 customers, how many should the business expect to be unsatisfied? First, let's talk about why this might be a reasonable situation. It would be difficult to survey 240,000 customers and get responses. So instead, the business surveys 500 and is going to expand upon that as the ratio. So if we're looking at how many we should expect to be unsatisfied, there are currently 35 unsatisfied customers out of the 500 they surveyed. We could reduce that if we wanted to, 7 out of 100. Using a proportion, we're looking for how many of the 240,000 we expect to be unsatisfied if we're looking at 7 out of 100 being unsatisfied in the survey. We cross-multiply 7 times 240,000, divide by 100 to get our result. So our result is that we would expect 16,800 unsatisfied customers out of our entire population. Let's try another prediction. Jared randomly draws a card from a 52-card deck and tries to guess what it is. If he tried this trick 1,040 times over the course of his life, what is the best prediction for the amount of times it works? He has one possible outcome out of 52 total outcomes. So there's one way he can be right out of 52. We want to see what that equals as a number out of 1,040. We cross multiply and divide, and we find out that we can expect Jared's trick to work 20 times if he tries it 1,040 times. We're going to do a few questions here. I'd like you to answer the questions, and at the end we'll talk about the answers. Question 1. Out of the 35 products a salesperson sold last week, 8 of them were products worth over $200. About how many of these products should the salesperson expect to sell if he has 140 customers next month? I'll give you a hint. 8 out of the 35 originally sold were over 200. If you expect to have 140 customers, how many items like that would you sell? There's your hint. Come up with the answer for the end. Question 2. Last week, 40 babies were born in a hospital, of whom 25 were male. If the hospital expects 264 babies to be born next month, how many would be male? I'll give you a hint. 25 out of 40 babies were male. How many out of 264 can we expect to be male? Question 3. Identify a fair game. You have 4 scenarios. I'll give you time to read through all 4. You decide, and then move to question 4. Moving on. Question 4. In a game, two players each roll a six-sided number cube and add the two numbers. If the roll is a 6 or less, player A wins. If the roll is 8 or more, player B wins. If the roll is a 7, the players tie and roll again. Is this a fair game? If necessary, take out your dice chart. Here are your solutions. Number 1 was 32. Number 2 was letter C and 165. Number 3, B. And number 4, yes, fair. If you got any of these wrong, take the correct answers, go back, and reread the situation. That's the end. Make sure your notes are filled out completely, including the questions on the left-hand side, and good luck.